So I'm here to talk about machine learning in the connected home. Right? So first a bit of an intro to what Domos does and how we do it. So we try to create perfect user experience for the end user in any connected experience. And we do that by our approach for doing that is making machine learning microservices that optimize for application outcome. And we want to do this on any CPE, and we want it based entirely on open standards. So, few buzzwords, a bit to go through, so I'll just start going through what this means. I'll also talk a bit about the approach we have and why the timing is correct, and how we do it, and some business benefits, and some takeaways, right? So I'm going to talk about two things. So it's like machine learning and standards is going to be the driving force for ISPs to create new revenue opportunities and better user experience. I come here as an example of a third-party service that if we have standards and machine learning, we can make better user experience and create revenue opportunities. And just don't forget, we got a live demo of some of what I'm talking about right outside at BBWF's Intro Pavilion. So that's it. Okay, so what the intro means. So machine learning, it's a bit of a buzzword. What it really is just a set of statistical techniques where you don't explicitly program, but you use inference and pattern recognitions to predict and optimize, right? And microservices is also a word that's got a few different definitions. So what I mean are services, small services that are loosely coupled, that can talk to each other, but doesn't necessarily depend on each other, right? And optimizing for application outcome. So by application here, I'm talking about actual applications. So Netflix, Skype, Fortnite, whatever. Not traffic class, not streaming versus video conference, but actual application. And the outcome is then translated to quality of experience. It's like, are your stream lagging? Can you do video gaming? And optimizing is just making the best use of what is there. And I think CPE and standards are given here. Okay, so where do we fit in? So to create the perfect connected user experience, you first start with the WAN, right? You need access line, you need technology. And after that came mesh networks, Wi-Fi management, channel planning, all of this. We're on top of that. We're about taking the resources that are there and assigning them, budgeting them for better user experiences. And it's a bit like, why do we do this? Well, it's because enough network capacity does not equal a great user experience. You can have enough network capacity to run multiple services at the same time, but because many applications, like streaming, like torrenting, are greedy by default, they take as much as they can that can interrupt something else, right? And that's how you get angry kids, because they're dying in video games, right? Okay, so why do we do what we do? So I come from a machine learning background, and when I studied machine learning, I had a professor who gave me like these few things that needs to be there for machine learning to excel. And first, machine learning is good when there's lots of complexity. If it's an easy problem, you can solve it simpler than machine learning, right? So you need this complex problem where you have multi-dimensional, very high-dimensional problems, and machine learning is good at finding those complex relationships and predicting for that. And that is what the home's like, right? You get this vast complexity of different end-user devices, different neighbors, different floor plans, different configurations, different CPEs, everything, right? And the second thing is, the data you have available needs to be able to predict. There needs to be predictional power in the data you have available. And there needs to be a reasonable amount of uncertainty. What I mean by that is, if you can look at the data and know everything, you don't need machine learning. If you can look at the data and you can't predict anything, You can't predict anything, right? And there's this good trait. In the home, it's like that because there's a lot of knowns, like how much are you using, your signal strength, etc. There's some unknowns. So you can't know what your neighbor is going to do in 5 seconds. You can't predict that someone is going to start a Netflix stream in 5 seconds. So you need this statistical approach where you can say, oh, I can give you a 95% chance that in 5 seconds you will have a good user experience. But you can't say for certain. And this is where machine learning is good. And there's also need to be some clear and predictable goals. And Andrea talked about QED project earlier today, which I'm going to mention a bit more, but that really just sets it. And there needs to be limited risk. I know next door is 5G, so they're going to talk about robot surgery. That's a high risk thing. We have a very, like tuning, configuring Wi-Fi and stuff like that is quite low risk. So that means you can explore the search space. You can try different configuration, and machine learning can learn what's the best way. Okay, why do we do this on the CP? And I want to make that point. We do this, we deploy deep neural networks on the CP. So why do we do this? Because you can do classifications, you can do optimizations and stuff like this in real time. Like you wouldn't do in a mesh network, you wouldn't do client steering from cloud. And we're the same kind of thing. We need to do things in real time to make sure that every application gets network resources it needs. And also an advantage of doing things on the CPE is that you can leverage a lot more privacy sensitive data. And you can make better estimations and better predictions. And a few years back, we tried to look at network quality, average over an hour, for example, from homes and trying to predict customer support calls. We found that there was not enough predictive power in network quality to predict, or in averaged network quality to predict customer support call. It just wasn't there. So we figured we have to go deeper and we have to do it. And also a point I will be making a bit more is that you can actually run this. So machine learning, I think most people think of it as very high resource demanding. And it is for training it. But when you actually have it finished, trained, and deploying it, it's very low resource demanding. Okay, so why do we optimize for application outcome? Well, different applications have different needs. I think it's quite okay. And why in open standards? For me, it's a bit hard to make this slide actually because it's very obvious to me. But one of the non-obvious things is that by having standardized APIs, you actually can reduce uncertainty. Because when we go from one hardware vendor to the next, sometimes we found in the past that signal strength there is not the same number as signal strength there. So you get these more uncertainties and you can make poor prediction. And huge point is that standards make us able to deploy our machine learning models and reduce friction, reduce risk, and just making it better. And it also, for the internet service provider, it just means that you can choose the best solution and not just the solutions you have because you're locked in. So why do we sell this to the ISPs? Where is the ISP's edge? The ISP is in the perfect position for bridging, for just knowing what end user experience is. Because you can bridge the WAN and the LAN. You're the only ones who can do it, so that's what we sell there. So when we want to make perfect user experiences, it's for us the obvious thing to sell to ISPs. Okay, so why now? Well, we've tried to make these third-party services for a few years, and it's been very hard. And you see that with a lot of the security companies, a lot of others, it has been very hard to deploy third-party services on CPEs, right? Because there's been a fragmentation in just about everything. But things are going the right way. And there is hope now, right? Because there are some superheroes among us. And these standardization organs and open source foundation makes this possible. And just quickly, for us to be able to deploy third-party services in a low-risk, good fashion, We combine USP, Broadband Forums, and Purple high-level API, as well as Linux containers, to make it possible to have very low risk and good deployments that can be remotely managed, that can be resource constrained, that can be access constrained. Okay, so quick architecture diagram. I don't think I have time to go through it all, so take a picture and I'll move along. So this is basically showing how we can use these to create these remotely managed third-party services that can be managed for memory, CPU, access control, security, etc. Okay, so Andrea's keynote this morning was about the quality of experience delivered project. Because of that, I'm not going to talk a lot about it, but just it amazed me when I came into this industry that if you ask someone how they measure network quality, everyone had a different approach. Well, QED is a framework for measuring network quality, and it combines all dimensions of network quality into single distributions, which you can see here. And that's what's important for us, that we can do this, because that's a lot easier to optimize for. And you can also make what is called a quantitative timeliness agreement, or QTA, where you can map the QoS requirements for an application in the same framework, which means you can actually, by combining these two, see the likelihood that an application will have a good outcome. Okay, so how do we do what we do? So we got these, I'm going to talk about 4 microservices we have here. So we have our application classification, which means recognizing what application is being used. We got our quality of experience delivered probe, which is an active probe for doing measurements. And we got a quality of experience delivered estimator, because you can't go around and probing all the time, we need to estimate this. And we also got our network resource orchestrator, which is about taking the knowledge about what applications are being used and the quality of experience they are getting and finding the best set of policies, configurations, and prioritizations for that. So first, our application classification. So this is one of our unique microservices. What we do is we observe metadata, so data about the data, things like packet sizes, device types, etc. And we classify the applications from that. And we got a very high accuracy for that. And first, we don't look inside the packets, so it's privacy friendly. It's also encryption safe, and we can train it for VPNs as well. And all of this, all the magic happens in one of our laboratories, where we have these laboratories for finding these signatures of each application. And then we deploy that on the CPU through the architecture I'll just show you. But it's very low CPU, low memory, low resource requirement on the CPU. All the hard work is done in cloud and in our labs. Next one is our quality of experience delivered estimator. This is a bit complex, but I'll start. So first of all, why do you need to estimate? Well, you can't go around. So the only way to properly be 100% sure of the network quality is by probing it. So you can't do that all the time, because you end up using all your network resources for probing, right? So you have to be smart about it. So our approach is having a artificial neural network, a deep neural network, that has been trained with data from active probing. So what we do is we do active probing, and we also observe what is happening. So the station information, the radio frequency information, etc. All of that goes in. And in cloud, we train that neural network, and then we deploy that on the CPU, right? But you also want a approach that is always improving, right? So every now and then we do active probing, and then we observe what is correct from the active probing with our estimation, and we use that, send that error to the cloud, and then we can always optimize, deploy new neural networks that are better. So you get this approach where you always are improving. And the output is this, like I talked to in the QED framework, a way of having a good way of having the network quality in single distribution, right? And we borrow a bit from environmentalists. We say, think globally and act locally, which is like you got this global learning database, but every home is different, so you need to actually make a different thing for every home, right? Okay. Finally, the last thing I'm going to talk about is our reinforcement learning approach for optimizing our network resource orchestration. So when you know what kind of applications are being used, and you know the quality of experience they are getting, then you have also a likelihood of there something failing. So, but then there's a complex problem of how do we make the best out of what we got. And we do this with another neural network, which is in a reinforcement learning approach, which is the same approach that AlphaGo and etc. does. So it allows the agent or the neural network agent to actually test opportunities itself and use that to create and learn and just always get better and better and better. And once again, what is run on the CP is just the forward pass. That can be done in microseconds, and all the learning is done on cloud. So you can actually deploy this on CPUs. Okay, just showcase that it is possible to do, active tagging of QoS and how it's different. Full system overview. So the environment, you measure the quality of experience delivered, you observe the environment, and you classify the applications. When you've done that, you can calculate the quality of experience, and then you can select a policy that maximizes that, right? And this all goes back into the environment, and you get this loop of learning, and you send data to cloud, so we can always get better and better and better and better. Okay, so what's the point of all this? Well, it's about knowing the quality of experience you actually deliver. It's not you had 50 megabits per second average last hour. It's Skype call was interrupted for 15 seconds, right? It's not, there was a packet loss at one device type. It was like what application and what it actually does. And you can tell that, oh, in this room, there is just not enough network quality to do video conference, for example. It's just a new level of knowing the quality of experience delivered. And that means you can do some next level troubleshooting. And again, to the ISP's position inside the home, connected with their knowing about what's happening in the WAN side, you can actually make an end-to-end troubleshooting, knowing exactly what is causing any problem. Because if you know the application, and you know what quality experience is delivered, and you actually use these frameworks and standardizations, do this all across your access technology and core as well, you can actually get this like pinpointing exactly where any issue are. Yeah, and a bit back to this, optimizing for application outcome is just about moving it like that, making YouTube greedy to that, right? Very often we have enough network resources, but it's just these greedy applications that destroys it for other applications. And we need this because Wi-Fi 6 is coming, but it's not solving all these problems. And there is tons of QoS approaches, right? But most of them requires the application itself to tag their QoS class, which they often either don't, or it's not policed, so anyone can tag their class whatever, so it doesn't really work. So we figured the only way of guaranteeing application outcomes is by estimating the network quality, and it is by recognizing the application and optimizing for that. And so we're actually going to start market testing what we call our gaming first approach now, where we actually detect the video game and optimize and prioritize that video game instantly. And we think there are people who are willing to pay for this. We've seen Haste, which is latency optimization. They charge $15 a month for latency optimization. And we think there will also be a video conferencing tool that we will be interested in this. So you can have a home office with guaranteed video conferencing. And premium, technical example, I think I don't have time for that. So we're showcasing the application classification in QED probe and estimation right outside, and we're doing that as a USP agent extension talking to Xera's USB controller on a K-on CP. It's very cool. It's also what the next panel is about. So if you leave it here with a few things, please standardize, use Purple high-level API, use Broadband World's USP, and use QED as a network quality metric. And it is possible to optimize for application outcomes. And please stay for the next session, so that's going to be really cool as well. Okay.